Hello, everyone. Welcome back. Today we are going to talk about proportional and non-proportional relationships. We are going to be talking about direct variations, and we're going to go ahead and get started. So today we're starting off with proportional and non-proportional. You're going to see a lot of what we do today based on what we've been doing, and we're also going to be talking about a little bit that we did when we were in school. So, proportional. Whether a function is proportional means that it must have a constant rate or ratio. Now, this is really important because you should notice it doesn't say quantities are proportional if they have a constant rate of change. It doesn't say that. It says they're proportional if they have a constant rate. Now, what I will tell you is if it has a constant rate, it has a constant rate of change. But a constant rate of change is a more specific thing. There's more details to it. It has more guidelines. So it just means something different. So today we're going to be talking about constant rates. We're not going to be talking about the change. You'll see they're very much intermixed because if it has a constant rate, it is the constant rate of change. But we're going to get to that when we do. So quantities are not proportional if they don't have a constant rate. So here we go. The first three examples say determine if the data shown in the table represents a proportional relationship. If yes, give the constant rate. So when I'm looking if something is proportional, I'm taking my points. So I'm going to take 12 and 2. I should say 2, 12. But when I write it in a fraction, I put the y over the x because that's how slope is formed and that's how we've been doing things and we're talking about functions. So I'm going to put 12 over x. I got a little excited there. 12 over 2. Sorry. Let me see if I can find my eraser. There we go. Just erase the whole thing. 12 over 2. Okay. So great. That's one of them. Let's pick another point because we need to figure out if it's consistent, if it's constant, if it's that line went array. If it continues to be a constant rate. So I'm going to take this 4 and 24 and I'm going to make it into a fraction. 24 over 4. And my question is, are these equal? And you should say yes. Because if I were to divide the top and the bottom, 24 divided by 4, I would get 6. If I were to do 12 divided by 2, I were to get 6. So what this is saying is that this has a constant rate. By picking out 2 points, I realize that they are the same and it has a constant rate. You may be wondering, why did you divide, Ms. Schultz? I divided because that's how we get our constant rate. And so our constant rate is usually given to us in unit rate form, which means we do our top divided by our bottom to find how much it is per 1. So our constant rate is $6 per 1 pound, which is $6 per pound. So yes, it is a constant rate, and the rate is $6 per pound. Okay. Number 2, if I were to go ahead and try and put these into fractions, so let's say I want to pick this top one, so I want to do 595 over 4. Is that equal to 9/15 over 8. And when I go ahead and I divide those two, so I do 5.95 divided by 4, and I do 9.15 divided by 8, I realize that those two numbers are not the same, and so therefore it is not proportional. This is not going to have a proportional relationship. And then I'm looking at number 13, and I want you to try it. So go ahead, pause, tell me, is it a constant rate of, does it have a constant rate? If so, what is it? And so is it proportional or not? Hopefully you did it. Okay. And you've hit play. So you should have said, yes, this is proportional. And when I put them into fractions, I realized that it was 38 words per minute. Okay. So number 1 and 3 are proportional. Number 2 is not. So again, I have these tables. How do I figure out if they are proportional? I pick 2 points. I pick 3 points. I pick all the points. I make them into fractions. Are all of my fractions equal? If so, it's proportional. If not, it's not. How do I find my constant rate? I do top divided by bottom. All right. So that is proportionality. So one of the things that us math people like to realize is there are so many terms that mean the same thing. So when something has a proportional relationship, it also has a direct variation. They're interchangeable. Okay? And so why do we teach you all of these words? We teach you all these words because sometimes someone refers to it as a direct variation. Sometimes people refer to it as a proportional relationship. You need to know they're the same thing. Okay? So when someone says, this has a proportional relationship, you can also say, it has a direct variation. So then we go ahead and we start talking about direct variation. And again, remembering that anytime we're talking about proportional relationships and direct variation, we're talking about there's a constant rate. Okay, so direct variation equation. When two variables vary directly, their relationship can be expressed through this equation. And you're probably thinking, where's the m? Where's the m? There's supposed to be an m. It should be y equals mx, because everything we've been doing is y equals mx plus b. Yes, but m always referred to the rate of change. This actually could be written as y equals mx. But the reason why it has to be k is because they want people to make sure that they're looking at the constant rate and not you're looking at the slope. Because the slope, I can have a slope, but it not be proportional. And the reason is because if I have a slope and a y-intercept that's something other than 0, it doesn't have proportionality. And so they talk about the k turns out to be the slope, but we have to make sure we're talking about k because we're talking about the rate. Okay. Every proportional relationship will turn into a line. Okay. So just understand that every proportional relationship will turn into a line. Not every line turns into being proportional. Okay. So that's why we take a separate day to do proportional and direct variation. So the equation is read, y varies directly as to x. Y varies directly as x. Okay. They directly they're directly affected to each other. There's no outside variable there. So K, which is the constant rate, is the ratio of y to x. Because how did we find the constant rate? We took a y and an x value, we made it into a fraction, we divided. So that's how K came to be. K is called the constant of variation. The constant rate can be called the constant of variation. I know I'm going super slow. I'm going slow because all of these, there's so many terms here. Okay. The last thing that we're going to do today, we're going to continue on this tomorrow, but the last thing we're doing today is we're going to look at these, and it says, so first, determine if they're proportional. So determine if the table is a direct variation. So in order to do that, I have to pick 2 points, put them as a fraction, divide, and see if they're equal. If they're equal, they're proportional. They have a direct variation. If they're not, there's nothing more that I'm going to do. But if they are, I'm going to write an equation to represent the relationship using this y equals kx here. Okay, so if I were to do number 4, I would put 4 over 2, and then I would do 6 over 3, and I would say 4 divided by 2 is 2. 6 divided by 3 is 2. So, hey, this one varies directly. This one has a direct variation. And so because it has a direct variation, I can take that answer to that division problem and make it into 2 tires per bike, because I got 2. So 2 tires per bike, which means the equation that I would represent would be y equals 2x. Okay. Now, if I would have said no, if these weren't equal, I would have been done. Okay. Let's look at number 6. Number 6 varies directly. Number 6 is a direct variation. It has a constant rate. I want you to pause, figure out what that constant rate is, and tell me what you think the equation is. Oh, wait a minute. This one is not. I made a mistake. Okay. I'm going to have to go back and clip that. All right, so this one is not a direct variation because 110 over 2 is not equal to 214 over 4. My bad. I'm sorry about that. I was thinking of another problem. All right, so that ends it for today. Sorry about that mistake on number 6. Bye.